Now, what is this bananas got to do with unsaturated hydrocarbons? And this picture,
The hydrocarbons is for ripening.
ripening, yes. The unsaturated compounds have effect on ripening. Right. That's the Friday next. We're going to have the test on chapter 12 and 13. Okay? So make sure you study. And right, today we're going to finish naming unsaturated hydrocarbon alkenes, alkynes, and also talk more about isomerism, geometrical isomerism, and then we do the reactions of alkenes. We already done reactions of alkanes. Only few reactions. Alkanes are inert, combustion and substitution of halogens. Only we look at the halogenation reaction. Compared to alkanes, alkenes have much more reactivity. There's many things you can do. Right. So we're going to talk about that in detail. We already done this part. Units of unsaturation. Do you remember that? What did I mean by units of unsaturation? Hydrogen bonds. That's a kind of a hydrogen bonds. It's kind of another phrase for bonding, right? The hydration deficiency, right, is the right word. I don't want to do inside certain wording, that has other meanings. You understand what I was saying? Right. Hydrogen deficiency, or how many hydrogens are missing. Ideal case is alkane. CN carbon is N, H is CN, the 2N plus 2. Now, write the name of the, I got it wrong. Write the names and the units of unsaturation for hydrocarbons. You have to find out among these what are alkenes, alkyne, and arene. Right? Now you have to understand what is arene. What is a arene? Arene is a general name for aromatic hydrocarbon. Remember we talked about three types of unsaturated hydrocarbons: alkene, alkyne, and aromatic hydrocarbon. Okay. If you look at this problem, what do you think this one is? Name. Of course, alkane. Alkane is the saturated hydrocarbon, and the formula you already knew. Okay, you already know this formula. This is the general formula for alkanes. What is the units of unsaturation in zero? Everything is compared to this. So that's okay. CN H 2N. What would that be? How many hydrogens are missing? One hydrogen molecule or two hydrogen atoms, right? So this could be a formula for what? Alkene. Is it only alkene? It could be, since this say unsaturation hydrocarbons, we didn't give a choice here. This could have been either alkene or cycloalkane also, right? But in this case, we didn't ask that as an option, right? So therefore, this answer should be what? alkene, right? The general formula is CnH2n. All right. Now this would have how many? Only one unsaturation. Okay. Now that one would have two, because how do you get now here this means zero unsaturation. This is -2. That means -2 hydrogens. This is kind of complicated, like we talked about it before. And this one is -4 hydrogens. Unsaturation is 2. This one is how many hydrogens are missing now? This is a different case. You have to look at the formula. This is complicated. There are too many hydrogens. It cannot be generalized. This could be alkyne. This could be benzene. All right. Therefore, you have to look at it. But somehow, when you have this is like a alkyne. This is alkyne. That this would be this would be is benzene, arene. Okay. Now arene has how many units of unsaturation? I think it has 4 units of unsaturation. Because arenes have this arene, we have only one of this, right? Question itself limits the answers. What is arene? Arene is a 6-membered ring cycle with alternating double bonds, right? Unit of unsaturation is 4. For example, benzene is one of the arenes. Okay. Okay, in here, the ring is 1 unsaturation, and each double bond is 1 unit of unsaturation. Then total is 4. All right? So that's how we interpret units of unsaturation in different compounds. Now the alkynes are, unit of unsaturation is 2, and this one is aromatic, is called arenes, all right? Arenes. General name for aromatic hydrocarbon is arene, right? So okay, this one is cycloalkane ring, also has alkene types. But if you say cycloalkane, and you have this formula, then it is a ring. If you don't say it's alkene, then it has CnH2n. That means it's a double bond, right, in the alkene, something like this. Okay, let me introduce some of the concepts. Ethene is the IPAC name. Simplest alkene is the ethene. Common name is ethylene. IUPAC, ethylene is the common name. It's like water or ammonia. People use certain chemicals before even they analyze them and thought about it. So we have common names like water. So propene is the, okay, let me back up a little bit. Why not methane? Can you have methane? One carbon alkene, why not? You had to have a double bond, right? To have a double bond, you had to have 2 carbons. I mean, that's kind of a question based on its structure. Now, is there two isomers in this molecule, propene? How about if the double bond is here? Is it an isomer? What do you think? It's not, because when you do this, you can turn it around, okay? Get the same thing, you know, like if you had this, if you have a model, you can rotate it around and you get that one, right? Same thing, superimposable, same molecule. But this one can have isomers. Now, this isomer is called 2-butene because 1, 2, 3, 4. Then how do you name? 2 means this ene is carbon atom starting with the carbon atom 2, right? Now, what would be the name of this alkene? Same argument. What do you say? It's butene. Where's the carbon bond? How do you locate? How do you name it? How do you number it now? This way, 1, 2, 3, 4, or this way?
Left to right.
Left to right, I agree. So you try to give these two carbons lowest number. That is the IPAC naming principle. So always you try to give the double bond the lowest number, then whatever other groups, right? Then we name. Therefore, this is going to be 1-butene, right? All right. So you got some idea about naming. Let me go back to IPAC naming here. What they're talking about is this: alkane, right? Whole idea is at the end alkene has ene, okay? Alkyne has YNE, ene, right? Okay, number the parent chain. That the parent compound going to be whatever the longest chain. If it is 6 carbon atom, if it is alkene, it's going to be hexene, right? If it is 2 carbon ene, triple bond, it's going to be ethyne. So number the parent chain to give the first carbon of the double, triple bond the lowest number. We've done that in butene. Remember, 1-butene, lowest number. Now you're no longer looking at the substituent alkyl groups. You're looking at the carbon atoms forming the double bond. General rules for naming alphabetical order. Remember all these things we talked about in alkane. For cycloalkane, double bond must be numbered 1, 2. Okay. If you had a alkene like this, that's hexane, cyclohexane, that's a hexane, right? This compound, okay. I labeled it. Longest chain is 4, butane, right? 1-butane. Why is 1-butane? That's the triple bond is starting from 1, and that's going to be a 3-methyl because 1, 2, 3, 4. You can go this way or that way, it doesn't matter. Okay, notice that when you have a triple bond, it's linear. The angles between carbon here is 180. Double bond is going to be 120. Single bonded carbon atom is going to be 109, tetrahedral. So we talked about that. Now when you are trying to do this, right? What is the longest chain? Longest chain is 7 here. We didn't start numbering from here. 1, 2, 3, 4, 5, 6, 7. Why not? 1, 2, 3, 1, 2, 3, 4, 5. in that case, this triple bond get higher numbers. 1, 2, 3, 4, 5, 4, 5. Now if you go this way, 1, 2, 3, 4, you get the lowest number, right? We don't worry about the any alkyl group, right? We identify the longest chain and try to give the lowest number to the carbon atom making the double or triple bond. That will be 3 heptane. You only label, give the number of the first carbon atom. Other one has to be the next. Okay, so that has to be 6 dimethyl, right? Heptane. Okay. Okay, now you are familiar with naming alkyne, alkene, and alkane, right? There are more examples. You can read those. That's called 1-hexene because you can have 3-hexene, you can have 2-hexene. You know, there are all different isomers, right? They are isomers, constitutional isomers. So the connectivity is different, right? Now, this one is hexene because 1-hexene. This is line angle formulas. So line angle formulas is much easier to label. You know, sometimes we convert condensed formula to line angle formula. Then we can see clearly alkyl group, substituent alkyl group. Okay, look at the way I name it. 3-methyl cyclopentene. Okay, there may be a problem here, what I did. Because labeling these 3 automatically nail down these as 1 and 2, okay? You see that? I put it here, you know, to be sure, okay? That this one here, they didn't write down one cyclopentene, because this naming that's 3 itself shows that other 2 carbon atom has to be 1 and 2, right? They had to get the priority. Okay. Now the let's go to questions now. Butane is 4 carbon atom. Okay, isomers of, this is the chemical formula. Then you can have different isomers. Okay. Now I could draw this 1 to linear form. 1, 2, 3, 4. Okay. That's one isomer. Of course, you already know what you already know from that table. Butane has how many isomers? Butane is 2. First alkane, which has 2 isomers, and pentane is 3, and heptane is 9. Okay, 2, 3, 5, 9, 18. Right? 2, 3, 5, 9, 18. Okay, now I'm going to draw for this. This is butane, N-butane or normal butane. Okay. And that is going to be isobutane. Okay, now you can draw your formulas here as well, like that. Remember, we got isobutyl group out of this, or tertiary butyl group, right? Okay. Now, Now I want to do, the carbon number is 4 here. Let's do a 1. This is not required, but this is kind of a challenge yourself, okay? C5. Okay, first one is this. 1, 2, 3, 4, 5. The second one is that one is good. Okay, this is called pentane. These are constitutional isomers, isopentane. How many of you remember I said that when you have a kind of this sign, the molecules are called iso. Okay, this is kind of a thing, iso. Neopentane is this. Now remember I talked about this, neopentane, that this carbon atom is quaternary carbon atom, right? All right, so now we should be able to do 6 also. 2, 3, 5, 9. The 5, 9 is next one. Okay. Okay. Can you draw 5? Okay. Of course, first one is this. All right. 1, 2, 3, 4, 5. Okay, 6. 6 is this. 1, 2, 3, 4, 5, 6. All right. So you can start with a branch here. 1, 2, 3, 4, 5, 6. All right. Now you can put the branch in the middle, right? Here. It's different connectivity. All right? All right. 1, 2, 1, 2, 3, 4, 5, 6. Okay. Now we have to get 5 of them, right? Okay. Now the other one is this, right? 1, 2, 3, 4, 5, 6. All right? So there could be another one here, 4, here. Okay, 1, 2, 3, 4, 5. Okay? Now, this one, they are distinct structures. Knowing that you have 5, you can look for 5, right? All right. Naming cycloalkanes. Of course, if you have 5 carbon atoms in the ring, is called cyclopentane. Because of the structural rigidity, like in alkene, you have cis and trans isomerism. Remember we talk about we talk about constitutional isomerism, conformational isomerism, and we talk about geometrical isomerism, and then we talk about optical stereoisomerism. These are called stereoisomerism, conformational stereoisomerism, because of the rigidity. Just like the double bond. This molecule, when you have 2 substituents, in a cyclopentane, this is still cyclopentane. Now, these dark arrows, dark means they are coming out same side. Okay. Now what we do is this. If you put a group like this on the same side, they are coming out same side. If I chain this, okay, this group to this side and put here, that one, they're different. Okay. We get the hydrogen. Okay, they're different. Now this one is called cis cyclopentadiene. Okay, you have to label 1, 2. 1, okay, cis. Always geometrical isomer is written in front of it. Like a D and L optical isomers are also cis. 1, 2, dimethyl. What is the rest? Cyclo. Hexane. Oh, pentane. Pentane. 5-membered. Alright. Now, for example, this line was, if this line was like broken, that's going to be cis opposite of cis. That would have been trans. So on the paper, I mean, if I show this, you're sure what it is. But we're not always doing things on the here. We do it on the books and the papers, right? So we wrote broken lines means going into the paper, the plane of the paper going into the paper, and the solid line means it's coming out of the paper. So it's called perspective drawing. All right. It's in the diagram, okay? The dark lines, if you can see, you can see little, right? Okay. I'm going to talk about, okay, 1, 2, 3. Either way you go, 1, 2, 3, 4. If you go this way, the substituent group get a higher number. One of them get higher number, right? You go shortest distance, 1, 2, 3. It doesn't matter which one is 1. They're equal, right? Only these are opposite sides of the ring. This is going to be trans, right? 1, 3, dimethyl, still cyclopentane. Okay. Of course, if you have a ring, then good observation, right? Okay, now you understand how to name alkenes, alkynes, and sites for alkenes, right? Now I'm going to ask you, revisiting what we talked about. I made remember that day? You are not, what was the, when you run into fractional numbers? Fractional numbers for stoichiometric coefficient for oxygen. When? Okay, when it's even. Okay, that's where, here, the problem, all right? This is okay. Now, even you don't have to know that when you're doing it, you figure that out, okay? So, sometimes I'm trying to get your attention when the problem happens. Okay, let's do it again. Okay, first you balance the carbon, 5, and 6. 12, 6. Now, 10 oxygen here, 6 oxygen here. Therefore, 16 oxygen. But there's a subscript here of 2. Therefore, it should be 8, right? No fractional numbers involved. But in this case, this is 4 and this is 5. Now when you multiply and get the oxygens, it's going to be 8. 4 times 2 is 8. 5 times 1 is 5. It's going to be 30. 8 plus 5 is 30. Okay. Now you put, because of the 2, when this oxygen number is even, you cannot multiply it by a 2 and get the number right here. These 2 cancel out, you get 30. Now what you have to do is, when you have this problem, fractional, then you multiply this by 2, this by 2, and this by 2. Then you got 10, that's the final answer, 8, right? And this is going to be 13. This is going to be C4, H10, oxygen, CO2. All right. Is that got? Now the one of the other reaction we talked about is halogen. These are still alkane reaction. Why I'm doing this is we are going to alkene reaction. I wanted to kind of contrast. These are the main reactions of alkene. Now we have though is called CH3Br plus HBr, right? Substitution, and the condition is light. when you expose it to light, this happens. Okay. But slower reaction, very slow reaction. You need light. Okay. Now you got that part. Okay. Now before I talked about alkene reaction, I wanted to introduce another concept about alkene, which has relevance to plant organic chemicals, biochemicals, the biochemical produced in plants. Right. Especially this one is called terpene. Okay. Let me get this. Like pheromones, we talked about pheromones, right? Other day, they contain double bonds in the structure that create properties that attract other insects. Right. Okay, this unit is called isoprene. Isoprene unit is this. I'm going to talk about this isoprene unit. It is like this. Now there is a series of compounds found in plants, especially in plants. I don't think terpenes are found in animals. I couldn't find any example for animals, but that the books specifically don't say where it is found. But terpenes are like lemon smell, lemon and lemongrass. Those are spices. Some spices have smells you add to food and fragrances, odors, created by these terpenes. One thing common to them is they are made out of isoprene units. For example, rubber is obtained from a rubber tree. You peel the bark. How many of you seen a rubber tree? Okay, a few. Because you're on North America, there's no rubber here. But if you grew up in the tropics or Philippines and all these tropical countries, have a lot of rubber trees. And there's a picture in the book. Do you see that the bark grows back again and they keep doing it again and again. Then they go back and start cutting again. See, where I grew up, this is very common. Then the people go and cut it in the morning and put the cup in here, and the rubber, this liquid comes out. It's a mixture of these isoprene units. Milk has isoprene, and it polymerizes. If you leave this rubber milk with acetic acid, you can get a thick gel type, rubber. Then you process it. You heat it up with sulfur and all that thing. We are very common to see in where I grew up, people in the bicycles, with rolled up sheets, trying to sell all these things. Anyway, this is the isoprene units in here. Now you understand these terpenes are coming from plant biochemistry. Now, I'm not sure what this is for. This is one of the terpenes. Terpenes are many. There are so many compounds. Even carotene is made from isoprene units. Beta carotene. Well, we don't call it terpene, but it's also made out of terpene. Now, terpene has this here is called a head, and this end is called a tail. Can you identify this branch? How many carbon atoms here? 1, 2, 3, 4. 1, 2, 3, 4. That's where it bonded to another one. You see that? It's a polymerization. Okay. What is the polymer? These are called addition polymers. There are many types of polymers. One is condensation polymers, other one is addition. Addition polymers are polyethylene. How do you make polyethylene? What is polyethylene? Plastic bags. They are stretchable and all that. How do you make that? What is the starting material for making polyethylene? Cut out the poly. What is the other part? Ethylene, right? Now polystyrene. What is the starting material? Styrene, okay? So polymer means like I can make a human chain, like holding hands with one, I'm doing that, okay? You can create a line, of people. That's a polymer, linear polymer of humans, right? For example, you could polymerization. You can have an ethylene molecule here like this, and you open up this bond here, and you have another ethylene molecule with here, oops, and here, and here, and on the other molecule open up double bond is end. This here make a bond. Now another ethylene molecule could do this. It's like what I talked about. I'm being a monomer. Ethylene is the monomer. Then connect hands with another person. That's a human again, and it's a human polymer, right? Human is the monomer, right? Like that. You got the analogy. These are polymers of isoprene unit. Okay. Now, do you see this is 4 carbon atoms? All right. That's where not here. Right here. This is the beginning of the next one. 1, 2, 3, 4. Okay. Now this is the next one. Okay. And 1, 2, 3, 4. That's the next one. Okay. I have a problem. 1, 2, 3, 4. Okay. Now, there's a problem. Okay. This is tail. It's head. You see that? I'm going to write here head and tail. No. Tail and head. Here. Here, tail and tails. T is a head. But this one is tail with the head. No. Tail and tail. You know what I'm talking about? Tail and tail. This one is, this is the isoprene unit here. Okay? Now, 1, 2, 3, 4. That is here. Okay? That's a tail. End of, this is where, here. Now that's a head. And this is a tail again, right? Here, 1, 2, 3, 4. And here, tail, head with the tail. Figure this out, okay? You have to look carefully where the head and the tail is. What is the giveaway? How do you figure out the head? The head is this part, here. All right? Now, how many isoprene units are in the following natural product? Named squalenes. How many? 1, 2, 3, 4, 5, 6. It's a polymer of isoprene, all right? I mean, in the body, there are enzymes that specifically manufacture different kinds of terpenes, right? Terpenes. So it's just like protein synthesis, that you create different proteins from amino acids. You could create, these are biosynthetic pathways in the body. But certain plants have genes activated genes for producing lemongrass oil. In the lemongrass plant produce an oil called lemongrass oil. Lemongrass produce lemongrass oil. It's a nice smelling, you use it in massages and things like that. So different isoprenes. It's a polymerization. Okay. Now how many of you understood what is polymerization? Polymerization is, what is polymerization? Addition of, there are different things. These are called addition polymers. Then no other thing produced. They are just opening a double bond. Nothing is given out. But some polymers, water molecule comes out, like a alcohol and ester combined, water molecule. They're called condensation. Condensation means water coming out. So these are called additional polymers. Okay. All right. Now, how many of you got the idea? If I gave you a terpene molecule, you need to identify the number of terpene. How many we counted here? 6 units. Okay, this is important to understand in chemistry. Okay. It doesn't look like I have time to go through reactions, but let's finish the naming. This is problem 6. All right. Problem 6. The first one, A, part A, is what is the name of the following compound? IFAC name. What is the first one? First one you should be able to do. What is it? How many carbon atoms? 7. It has to be heptane. Okay. Now this one is a branch alkane, right? What would that be? The longest chain is what? 3. Both ways numbering is the same, either way. Then this goes the 2-methyl, right? All right. So this is called 2-methyl propane. 3 carbon atom parent chain is propane. Okay. How do you do this one? Okay, where you start labeling here is what is the longest chain now? How many carbon atoms? 6. Okay, where you start numbering here? Left to right or right to left?
Right to left.
Because these branches should get the lowest number, just like alkyl group, right? 1, 2, 3, 4, 5, 6. Okay. Now this is going to be, what is this called? Substituent group when it's a bromine, it's called bromo, fluoro, halo. Halo is the generic name. This is going to be 2-bromo. Okay, this is going to be 2-bromo as well. Okay, now this is 4-bromo. Okay. Now, what is the name? It's 6. It's going to be hexane. All right, what is the other part? Tribromohexane. It has to be tribromo. Why tribromo 3? Okay. Then you have to go 2 to 4. Okay. You get it? Okay. Now we've been through difficult ones. You know. Now we can do the simplest one. Now this is, how do you name this compound? It's an alkene, right? And alkene, what kind of alkene it would be? Propene. Do you need a 1 or 2? No. Because even if you put the double bond here or there, it's going to be the same molecule. There's no isomers. That's called propene. I'm giving the, now common name is, for this one, if there's a one, I think ethylene has a ethylene and ethene. Acetylene has a acetylene common and the ethene. But the higher ones don't have common name. Propene. I don't think we have a common name. All right. Got that part. Now there are more, I guess. Now what is this called? Is it trans? You have to have another group, okay? To be a geometrical isomer, you have to have 2 different same group, in this way. It's just showing that this is coming out of the plane, but it doesn't mean it's trans. Okay? To have a trans, you have to have another group. Okay? Both up and down, broken line or solid line. Okay, this one is propene. No, pentene. I always get that. Okay, 1, 2, 3. Okay, we already done that. 3-methyl pentene, cyclopentene. Okay, now this one. This is the alkene. Again, longest chain is what? 1, 2, 3, 4, 5. Which way you number the right to left? 1, 2, 3, 4, 5. Okay, that's going to be 4-methyl. Okay, this group, therefore 4-methyl. Pentene. All right, you got it. Now this one is.
Dr. Paul.
Yeah.
Would you have to do the 2,3 pentene to show where
right,
the bond is?
Right. 2. Now you have a carbon atom. You have to do this. Okay. Right. Okay, this one is a alkyne, YNE. What is the longest chain here? It's 5, right? So which way you number the carbon chain now? Left to right. 1, 2, 3, 4, 5. Therefore, there's no substituent, okay? Pentine, PYNE. That's going to be 2-pentine, okay? Now this one is, okay. Now let me tell you something. If the double bond is, there's only one group here. Only if there's a hydrogen here, there's no thing. There's not going to be geometrical isomers. to have geometrical isomers, have two groups opposite to each other across the double bond, or they across the ring, or same side of the ring, or same side of the double bond. Right. So in this case, if there is hydrogen here in these molecules, CH3, CH, CH2, CH, CH, CH3 of hydrogen, there's no geometrical isomer. But here you have that. Of course, this is going to be cis strands. Then now we have to label it 1, 2, 3, 4. Butene. It could have been 2 butene, 1 butene, okay? But in this case, it had to be 2 butene. Then you have to say cis 2 butene. See that? Now this one has to be, this is the line formula, in the middle carbon atom is has to be trans 2 butene. Geometrical isomers are called stereoisomers. Right. Okay, I'm going to stop and do the review of alkene reaction next time.